Okay, so now we're going to look at the essential questions. How do the values of A, H, and K affect the graph of the absolute value function? And so A would be a number in front of the absolute value bars. K would be a number added or subtracted at the end. And then H would be a number inside the parentheses or the absolute value bars. So how would that affect it? Not if they're parentheses, but absolute value bars. We've already talked about how they would affect it if it's parentheses, whether it be a translation or reflection or whatever it is. So let's look at absolute values now. So an absolute value function. An absolute value function is a function that contains an absolute value expression. The parent absolute value function is f of x equals x. So this is the one that everything else is based on. The graph f of x equals the absolute value of x is v-shaped. You can see it right here, it's shaped like a V. It's symmetric about the y-axis. So whatever's done on one side is exactly done to the other. The vertex is the point where the graph changes direction. So right here is the vertex, that's the right tip where the two lines meet. And the vertex of the graph of f of x equals x is 0, 0, so the origin. And then if you notice something, with f of x equals x, the absolute value of x, it's very similar to f of x equals x. Similar in the sense that the slope goes up 1 and over 1, up 1 over 1, up 1 over 1, and then on this side, up 1 over 1 to the left, negative 1, up 1 again, another 1 to the left. So instead of the line going continuously as a positive slope, it has a V-shaped with the vertex at 0, 0. And then the domain of f of x equals the absolute value of x is all real numbers. So if you think about it, every number, because of these arrows, is included. And the range, well, the range is not every number because there's no negative numbers. So the range is that y is greater than or equal to 0. Okay, so as far as the range goes, it's going up, but it's not going down. Okay. All right. So now let's look at some real examples here. This is graph each function, compare each graph to the graph of f of x equals x, the one we just, absolute value of x, the one we just looked at. Describe the domain and the range. So first, let's break this problem down. We're going to first make our little change here. We're going to change this f of x equals x, the absolute value of x, with this equation, g of x equals the absolute value of x plus 3. Now, one way to do this is just to figure out what each point would be. So, if we were to put a negative 2 in the absolute value of g of x equals the absolute value of x plus 3, well, you would have g of x equals, and what's the absolute value of a negative 2? Well, it would be a positive 2 plus 3. So, if you put in a negative 2, what do you get out? Well, 2 plus 3 equals 5. So if you substitute in a negative 2, your output would be a 5. What if you were to put a negative 1 in? Well, you would have a negative 1 plus 3. Well, negative 1 plus 3. But what's the absolute value of a negative 1? It would be a positive 1 plus 3, or 4. You put a 0 in, you would have a 0 plus 3, which is 3. What do you think would happen if you put a 1 in? Do you think it would keep counting down? 5, 4, 3, 2, 1? Let's find out. So if we substitute a 1 in, let's flip this around, we would have g of x equals the absolute value of 1 plus 3, but 1 plus 3 is 4. So it didn't continue to count down. You can see that this is how that v is going to start to happen. 5, 4, 3, 4. It's going up. And then maybe some of you can guess the next number. Well, if you substitute a 2 in, 2 plus 3 is 5. Okay, we're going to graph this in just a second. But while we're here, let's go ahead and do the other one, the x minus 2. So if we put a 0 in for the absolute value of x minus 2, it would be 0 minus 2. And the absolute value of 0 minus 2, well, the absolute value of a negative 2 is a positive 2. A 1 minus 2 would be a negative 1, but the absolute value of a negative 1 is a positive 1. 2 minus 2 would just be 0. 3 minus 2 would be 1. 4 minus 2 would be 2. So we have these filled in. Now let's go back to this one, and let's see what it'll look like as a graph. So I went ahead and graphed the parent function, the f of x. Let me move this out of the way for a second. F of x equals x. And you notice that it's going up 1 over 1, up 1 over 1, right? Well, what if we were to, I'm going to put this on top, what if we were to change it with g of x equals this, x, absolute value, but plus 3. And actually, I can see I made a mistake. I didn't put absolute value bars there. So it's the same thing as this, but you're changing it by 3. Well, we remember earlier that when the function g is of the form of y equals f of x plus k, that k at the end is either a upward movement or a downward movement. And if it's positive, it's upward. So we're just taking it, we're moving it up 3 units. 1, 2, 3. Moving it up 3 units. And that's the answer. Now, if we were to go back to our chart here, we would see that it works out. When x is a negative 2, the g of x is 5. When x is a negative 2, the g of x is 1, 2, 3, 4, 5. It's on the line. If x were a 1, the g of x would be 4. If x was a 1, the g of x would be 4. So you can see that any point here would correspond to this. But it is kind of easier to me just to count 3 up. 1, 2, 3. Than to go by each point, you know, like a negative 1 and a 4, and then put the dot for each point. It's easier just to count up. But if you do count up, you have to keep the same slope. So this went up 1 and over 1, up 1 and over 1. This went up 1 over 1 to the left. So this has to keep the same slope. Up 1 over 1, up 1 over 1, up 1 over 1 to the left, up 1 over 1 to the left. So as long as you do that, you'll have the right answer. So this would be the transformation of g of x from f of x. Now, let's look at the second one here. What if we had, let's look at the second one really quick. M of x equals this f of x here, this x, minus 2. So we still have the same f of x, but now we're going to do this minus 2. You may recall that when it's minus 2, we're going to move it either to the left or to the right. And when it's negative, which direction does it go? It goes to the right. So how many times do we move it to the right? 2. So 1, 2. And that would be the answer. And if you look, that corresponds to the chart we made earlier. But let's say that you there's 2 other ways you could do this. You could just use the chart, right? You could say if x is 0, the y is 2. If x is 0, the y is 2, and chart it. If x is 1, y is 1. If x is 1, y is 1, and you could chart it. If x is 2, y is 0. If x is 2, y is 0, and chart it. If x is 3, y is 1. If x is 3, y is 1. And you could just do it this way, and you would come up with the same answer. See, but I find it easier than you know, plotting each coordinate and then connecting the dots, just to take the one coordinate, just to take the vertex, moving it over 2, because it says it's a transformation 2 units to the right, and then just keeping the same slope. The slope is up 1 over 1, up 1 over 1, up 1 over 1, so just keep the same slope, up 1 over 1. To me, that's the faster way to do it. Okay, it is now your turn to try this. Good luck.